So, welcome back to this quantitative finance course. So, till now and in the last class which we ended, we discussed about different other portfolio optimization problem. When one is being that you want basically have the geometric mean, another case you have the safety first principle, or else you maximize the return of the portfolio or try to basically maximize RL. RL means some cutoff over which you definitely want your portfolio returns to be, and so on and so forth. Now, today's class or lecture would be more to do with trying to understand different forecasting or simple averaging techniques, and they are generally used in order to find out the average prices on a long run considering there is fluctuations, and how you try to basically do this averaging prices without going into details of the time series. This is not the time series part of the quantitative finance course which we did mention during the discussion of the syllabus. We will come to the time series part later on. So, consider that you have this diagram where the black dots are all the different type of actual values which you have, and the green, blue or the red one are basically the best fit lines which you are trying to basically fit in order to basically predict or forecast what would be the future values of the so called prices or so called trend analysis, trying to find out the trend analysis of different type of so called time series values. Now, you should remember one thing, that along the x axis you have the times, that means they are of unit intervals, like it can be in month, it can be days, it can be weeks, it can be in seconds, whatever it is, and along the y axis you basically the values. So, what you actually would have is this. So, generally you will have F1 which will be the price of a particular product at time period is equal to 1, F2 price of the same product at time is equal to 2, and so on and so forth. So, if you have n t number of such data points, they would be F1, F2, F3, F4, so on and so forth. So, what you want to do is that you want to utilize the values of F1 to Ft in some way in order to basically predict the price or the value at of that function or of that value at Ft plus 1. So, how it is done? We will see that in a very simple way, trying to utilize the concept of averaging techniques. Let us go into directly into an example that will give you a much more practical flavor of how you try to solve. Consider you have actual data in values for month wise it is given. So, what you have is month wise values starting from January, February, March till December, and these values are in either rupees or in dollars, in numbers, whatever it is, this does not matter. So, the values basically start at 266 for month of January, as you can see here. Then it basically ends at 649, which is the December. So, what you actually have is January to December is 1 year, then January to December is second year, and January to December is third year. So, 3 years data are there. So, 3 into 12, 36. Now, let us consider the concept of odd moving averages. So, if you see there are a 3-month moving average, 5-month moving average, and it can be made into 7-month, 9-month, 11-month, whatever it is, but we will just simply consider the third and the fifth in order to understand how the odd moving averages are done. So, if you see the actual 1 in 98 value which is there is basically the averages of these three. Then if you go to 149, it is basically the averages of these three value, and as you move, what you are doing is that you are trying to find out the average of Ft, this is small t, plus Ft plus 1 plus Ft plus 2 divided by 3, and the value which you get would be the predicted value which will denote by F hat for the time period t plus 1. So, in case rather than t, if you had say for example, Ft minus 1 plus Ft plus Ft plus 1 divided by 3, then it will basically give me the average value based on which you will try to predict for the value of F hat t. So, similarly, the value of 160.9 is basically the average over 183 plus 119.3 plus 180.3, add them up, divide by 3, and you basically proceed step by step as you do that. Now consider the 5-month moving average. So what you are now doing is for the 5 month which is 178. So let me use a different color in order to make you understand it much better. For the value of 178.9, now you are taking the averages of 5 values, the middle one being 183 and the 2 preceding and the 2 succeeding one once considered are these values. So what you are doing, you are adding up 5 values. So technically you would be adding f t minus 2 plus f t minus 1 plus f t plus f t plus 1 plus f t plus 2 divided by 5. So f t minus 2 would be 266.00, f t minus 1 would be 149.90, f t would be 183.10 and so on and so forth. So now if when you proceed to 159, what you will do is that you will just move one shift. That means the f t minus 2 would now be 145.90 and the last value would be now 168.5. So you have 145.90, 183.10, 119.3, 118.3 and 160.5. So this will be 1, 2, 3, 4, 5. So correspondingly you move. If you consider 7 values, it will be, which I have not noted down. If you have the 7 values, say for example you want to find out the 7th value here. So what you would do is that you will take these 3 first, then these 3. So this is the middle value. So this would be f t minus 3, f t minus 2, f t minus 1. This is f t, this is f t plus 1, f t plus 2, f t plus 3. Add them up. How many values are there? 7 values, divide by 7. Similarly, you go for the 9th, 11th, so on and so forth. So if I plot these values with time along the x axis from January to December, January to December, January to December, that is 3 years, then the yellow one is the actual one. So you see there is a fluctuation in the yellow lines. So I am not trying to basically mark it because the color scheme then would be disturbed, then you cannot understand. The blue one is for the 3-month moving average. So if you see, the blue month fluctuations are much less the yellow one, because what you are trying to do, you are trying to basically average out for the plus and minus fluctuation, and divide by 3 would basically bring down the fluctuation to a quite great extent. Further on, if you consider the red one, which is the 5-month one, you will see this is almost smoothened out. So any positive negative fluctuation which you had in the actual values, which is the yellow one, would not be shown or would not be apparent if you basically check the 3-month or later on the 5th month or the 7th month moving average. But what you are trying to find out is, rather than predict the actual values, you are trying to basically find out the trend analysis based on which you are able to at least gauge or understand in which direction the prices are movement and how the prices can be predicted using other methodologies, but this moving values concept would give you good data or a good hunch that in which direction and what is the overall trend of that overall price movement or the value movement, whatever it is. Now let us go to the even numbers. So again we consider the same data set, January to December, again January to December and January to December. So there are basically 3 months. Now if you see the second column, again is the actual value, here also is the actual value. But now the even number movements is a little bit different. So they will see it is 4 month 1 and 4 month 2. So what you are doing is that, say for example, if you see the values, so if you take the 4 month average, then it will be either 1, 2, 3, 4, but in this case when you are trying to find out the 178.58 value, there would be 2 values before that. So what you are doing is f t minus 2, f t minus 1, f t and f t plus 1. So obviously the skewness is more towards the upper values or towards the previous values. If you consider the 4 month second average, which is here, rather than putting more weightages to the prior values, you will now basically put more weightage to the future one, which is, now you will consider, let me take a different color, you will consider this as first, this as second, this as third and this as fourth. So, now your shift has been more from the left, that means the left was this part onto the right. So, once you have that, you find out the averages of this average. So, once you have the averages of this average, what you are trying to do is that you are trying to basically equally weight any positive and negative movements. We will come to that concept within 2 minutes, and that will give you a very good concept that how the concept of normality would also be brought into the picture. So, if you proceed in this one, if you have a 6 months one, so what you will do is that in the 6 month one, you will basically take one extra reading prior, and the second case you will take one extra reading post, add them up, divide by 2, and basically you will have the actual averages values accordingly. Similarly, if you find out the 160, 157 value, then obviously you are taking that 119.3 definitive value would be there, but in the first case 145.90 and 183.10 plus 180.3. So, what you will basically have these 4 values 1, 2, 3, 4, which is ft minus 2, ft minus 1, t, t plus 1, that is for the 4 month moving average 1. When you go to 4 month moving average 2, so rather than take 145.9, you will just shift one step forward, which means ft minus 1, ft, ft plus 1 and ft plus 2, such that once you add up divide by 2, they would be smoothened out. So, the more you do such averages, it will basically smoothen out considering any positive negative fluctuation both for the past data more down the line and the future data more down the line. You are basically trying to give less weightages to such extreme such values which are there from the center or from the state from where you are trying to find out the averaging technique. So, if I basically plot this graph for the case of the even month moving average 4 month 1, 4 month 2 and 2 into 4 month average, again yellow is the actual one, the red and the blue one are the 4 month average 1 and 4 month average 2. So, obviously you see there is some fluctuation, but these fluctuations are happening in such a way that if you add up both these values, which is basically the red and the blue one, you will get a much more smoothed line, which is the green one, which will give you a much better prediction or forecasting for the overall fluctuation which is happening for the actual data. Now, consider the 4 month 1, 4 month 2 and the average technique. So, say for example, you are trying to find out the averages of 4 units at a time. So, have a very careful look at this. You take the first value, consider y1 is the first value, second value, third value, fourth value, divide by 4. So, what you are doing is that you are giving equal weightages of 1/4 or probabilities of 1/4 for each of the values, which is y1, y2, y3, y4. Now, if you go to the 4 month average 2, you see there is a slight shift onto the right. That means, you are going more towards the future and basically subtracting one value from the past. So, as you go one step forward, you delete one of the back values and then basically include the front value, which is exactly what is happening here. You take y2, y3, y4. So, as you have subtracted y1, you take y5. So, again you add them, divide by 4. Now, in the next step, this is total process is not complete. In the next step for the moving average even, what you do is that you add up 4 MA, which is moving average 4 step 1, and then you add up with moving average 4 step 2. This is step 1, step 2. Add them, divide by 2. So, once you divide by 2, what you actually have here dividing by 8, but look at a very interesting value. Y1 is being only added once, so it will be y1 divided by 8. That means, you are putting 1/8 of its probability to the y1 value. Now, consider y2. Y2 has happened twice. So, what you basically do is that you are trying to give 1/4 of the weightages to y2, that means, which is 2 by 8. Similarly, if you find out y3, it is twice, y4 it is twice. The overall probability for y3 and y4 is 2 by 8, which is 1/4, and again at the last end when you add up y5 for the step 2, you divide by 1/8. So, the overall probability is 1/8. Similarly, you can have twice into 6 month moving average, twice into 8 month moving average, twice into 12 month moving average, depending on what you do. Now, what is important is these, not y's, but basically the coefficient. So, if you look at y1, the coefficient is 1 by 8. If you look at y2, the coefficient is 2 by 8. If you look at y3, the coefficient is 2 by 8. y4 again coefficient is 2 by 8 and y5 is 1 by 8. Now, if you draw a histogram where along the y axis you basically plot the y values and along the y axis you basically plot the overall relative frequency. So, if you plot the relative frequency y1, it is 1 by 8. That means, out of the 8 such readings, you are basically putting 1/8 or 1 by 8 into 100 overall weightages percentage wise on y1. For y2, y3, y4, it is just the double, and again y5 is exactly equal to y1. If you continue doing it, you will see a very interesting trend. Consider that you take, say for example, rather than 6, you take 8 and do 2 stepwise averages or 3 stepwise averages. So, if you do that, in the long run what you are actually aiming is to put the weightages depending on a very simple histogram. Now, keep doing it. The more you do, more smooth than the histogram would be, in the sense that if you plot the midpoints of the histogram, they will slowly turn out to be the normal distribution, which means that you are considering a priori the intrinsic distribution based on which you are trying to find out is normal, such that the average value or the middle value where you are trying to find out the averages, that is the mean or the median or the mode for the normal distribution, and more further down, means more back to the back or more to the front you go, you are basically giving less and less weightages, less and less relative weightages to the overall values which you are considering, which is right, because as you are standing today, you will try to basically give the maximum weightages. For any past value, any futures value, obviously you will consider them, but consider them to a less probability sense. Now, consider the y3, but we are basically considering the y3 in such a way that we are also taking the averages of this also. Very simple, just you are trying to now extend this concept where the concept of probability using the histogram will come out very smoothly. Consider that when you are trying to find out y3, you add up y1, y2, y3, that is step 1, you divide by 3, obviously there are 3 values, you divide by 3. So, if I ask you a question, what is the corresponding probabilities for y1, y2, y3, you will immediately say the probabilities are 1/3, or means out of the 3 you are putting 1/3 or 33.33% weightages on y1, similarly on y2, similarly on y3. Now, move one step forward, that means you delete y1 and include y4. So, if you see in the step 2, what you have is y2, y3, y4 divided by 3. So, now you are putting for this step 2 33.33% on y2, y3 and y4 respectively. Again move one step forward, delete y2, include y5, add them up, what you are adding? y3, y4, y5 divided by 3. So, if you find out, again the overall percentage which you are putting on the weights for y3, y4, y5 are all equal and equal to 33.13. But the interesting fact is that now you have 3 terms, step 1 term, step 2 term, step 3 term. So, if you want to find out the average, what you will do? Add them up, divide by 3. So, exactly that is what I do. So, once you do that, you find out the weightages which is coming out for y1 is 1/9, weightages which is coming out for y2 is 2/9, weightages which you are giving for y3 is 3/9, weightages for y4 is 2/9 and weightages for y5 is 1/9. So, if you plot the histogram again, along the x axis you have basically the y values, along the y axis you have the corresponding relative frequency or the probabilities. Then you find out y1 has a height of 1/9, y2 has a height of 2/9, y3 has a height of 3/9, y4 has a height of 2/9, y5 has a height of 1/9. So, if you continue doing this, slowly again as mentioned, you will slowly replicate the normal distribution, which will basically go into the intrinsic assumption, which is absolutely right in the case that the more you are centrally located, obviously you will get more weightages to those values if you have the past data in front of you, and for any aberrations in the sense that you move backward and forward, you will basically give less weightages. So, further you go down from the actual state where you are in, you will give less and less weightages, which means that if you are standing on y3, the overall weightages you are putting for y1 and y5 is 1/9. But closer you come to y3, the weightages you are putting on y2 and y4 has increased from 1/9 to 2/9. So, obviously, when you are at the position y3, you will give the overall weightage to the maximum, which is 3/9. So, in general, a weighted k moving average can be written by this. So, now we are trying to give some weightages on the probability. So, if we have, say for example, standing at 0th level and you go to minus m on to the left and plus m to the right, what you do is that you add up all these y values, but when you are adding them up, you are putting weightages. So, from where do I find out the weightages? As just discussed in the last slide, the values of 1/9, 2/9, again 3/9, again 2/9 and 1/9 corresponding to y1, y2, y3, y4, y5 are the corresponding weightages which you have. And obviously, remember another thing, if you go back, if you add up all the relative frequencies of the probabilities, what you have 1/9 plus 2/9 plus 3/9 plus 2/9 plus 1/9, it comes out to be basically 9/9, which is 1, which is intrinsically the corresponding probability says that when you add up the probability, you should definitely add up to 1. Remember, the total weights equal to 1 and weights are symmetric. So, if it is symmetric, it basically gives you an intrinsic feel that the overall distribution you are going to consider for this moving averages is basically the probability distribution which is normal. So, consider the moving averages and steps. I am basically now expanding them, considering the 4-month moving averages, but I am taking basically 4 different steps. For the first one, it is y1, y2, y3, y4 divided by 4, because there are 4 values. For the second step, you basically delete y1, include y5. Again, it is y2, y3, y4, y5 added up, divided by 4. And the next step, which is the third point which is written here, now you have again moved one step forward. That means, initially you have deleted y1, now you are deleting y2. So, as you delete 2, obviously values you basically will take 2 values, which are basically y6 and y5 are added. So, now in the third step, the values are y3, y4, y5, y6 added up and divided by 4. Similarly, for the next step, it is y4, y5, y6, y7 divided by 4. Now, how many such times did you take y4 average of 4? 4 times. So, what you will do? You will add them up, divide by 4. So, that means the overall denominator will become now 4 into 4, it is 16, which is exactly what is it. But now, it will become more apparent what are the weightages. Y1 is only appearing once. So, overall weightage is 1/16. Y2 is appearing twice. So, it is 2/16. Y3 is 3/16. Y4 is 4/16. Again, it starts decreasing. 3/16, 2/16, 1/16. Add up all the probabilities. 1 plus 2 plus 3 plus 4 plus 3 plus 2 plus 1 divided by 16 comes out to be 1, as mentioned in the last slide where the weights add up to 1. And also see is a histogram very simply. If you draw, the histogram has the heights of 1/16 in the first leftmost corner, and the rightmost corner is symmetric, again height of 1/16, and in between you have heights of 2/16 here, 2/16 there, 3/16 here, 3/16 there, and the middle value is the highest, which is basically the mean, median, mode, whatever you say for the normal distribution, and the weightage is 4/16. Similarly, you can have basically 5 method for other different time moving averages, which are basically much more intricate, much more nice, depending on what you think would be the overall weightages as you basically go further down in the back or further down basically in the front, which means standing today you are trying to take values from the past and from the future, and depending on that you will basically give weightages accordingly.